Bam! Mr. True. In this video, we're going to be taking a look at 3 examples involving sum and difference identities in trigonometry. This might be in a section of your book called Trig Functions of Any Angle, and then we're going to put an interesting question here as our 3rd example that you may or may not see in a standard trig book, but it is something that my kids may see in their IB course. So we're going to go ahead and you will find timestamps to the 3 examples in the description of this video. If you want to jump ahead, you'll also find links to videos that I've done also for this topic. And moving down here, we have the identity, which is for sine, that the sine of 2 angles being added or subtracted together is going to be equal to the sine of the first angle times the cosine of the second angle. And in between here, I'm writing identities for both plus or minus, and I'm going to keep the plus or minus in the same order. And I'll explain what that means in a second. Sine of the first times cosine of the second times the cosine of the first times the sine of the second. And when you see this plus minus in your textbook, they're basically just trying to write 6 different identities as 3 because they're so closely related. The fact that we have a plus over a minus, and inside on the right-hand side of the equation we have that plus or minus in the same order, means that the sine of 2 angles being added together is the sine of the first times the cosine of the second, and then we're going to keep that plus sign, cosine of the first, sine of the second. And if you have a minus sign between these angles, then we're going to have a minus in between these 2 terms. So we're going to be subtracting those 2 terms. Now, if we look at our sum and difference for cosine, we have the cosine of 2 angles that are being either added or subtracted together is going to be equal to the cosine of the first times the cosine of the second. And now we're going to change the order of those plus or minus. And we have the sine of the first times the sine of the second. And where we have the cosine of 2 angles being added, that's going to be the cosine of the first times the cosine of the second angle, and then minus sine of the first times the sine of the second. So if you see a cosine of 2 angles being added together, the right-hand side of the identity is going to have 2 terms which are subtracted. There's a sign change with the sum and difference of cosine as opposed to the sum and difference of sine. If there's a plus sign, there'll be a plus sign on the right-hand side. And the cosine of 2 angles subtracted is going to give you 2 terms that are being added together. Now, for tangent, you can derive that on your own by saying that the tangent of alpha plus or minus beta, you could focus on maybe just the sum of these 2 angles, and you can write this as the sine of alpha plus beta over the cosine of alpha plus beta, and use the sum and difference identities that I just gave you up here in line 1 and line 2, and actually derive the formula for the tangent of 2 angles being either added or subtracted together. I'm going to not do that proof for you in this video so that we can keep this relatively short and get to our 3 examples. So let me just write this out. We have the sine of the tangent, of 2 angles being either added or subtracted together is equal to the tangent of the first angle, and then we're going to keep that sign the same. So if there's a plus in the parentheses, then it remains positive, or if there's a minus, it remains negative, with the order here plus over negative being the same, which indicates that whatever sign is here is the same sign that you have on the right-hand side. Now that's going to be tangent of alpha plus or minus the tangent of beta all over 1. Now in the denominator, you're going to see the order of these signs change. 1 minus or plus the tangent of alpha times the tangent of beta. And actually, what we can do here is really make sure that you understand the color coding here. If this is minus, then over here it's minus. If this is minus, then over here it's plus. If this is minus, then you have a minus of 2 terms in the numerator and a plus 2 terms in the denominator. So keeping that in mind, we are going to come down here to Bum-ba-da-da. So for example number 1, we have the sine of A is given to us as a ratio of -1/3, and we were being told that that angle A is in quadrant 3 because it's between the angles of pi and 3 pi over 2 radians. We have the cosine of B is given to us as a ratio of 1 over square root of 5, and we're told that angle B is going to be in quadrant 1, where angle B has the measure, takes on the measure of between 0 and pi over 2 radians. And we're going to find the cosine of A minus B and the tangent of A plus B. Now, we're going to let these identities simply tell us what they need so that we know how to work through these problems. So the cosine of two angles being subtracted together is the cosine of the first times the cosine of the second. And we're going to change the sign there and have plus the sine of the first angle times the sine of the second. Well, great. We have actually a lot of this already given to us. We're told that the sine of A is equal to -1/3. So let's go ahead and put that in. And the cosine of B is being asked for, and that is a ratio that's also given to us. It is equal to 1 over the square root of 5. Now, if you were to rationalize that right now, you would have the square root of 5 over 5, and you'll have a correct answer. It'll just be a little bit different, it'll look different than what I'm going to have as my final answer, because I'm going to leave that in that format. And whether you do or not is just personal preference and whatever you're happy with. If it's a multiple choice question, you're going to have to make the form of your answer match one of those multiple choice answers. So we're being asked for the cosine of A. And eventually, we're going to need to know what the tangent of angle A is. So we're going to have to recall on our skills that we've already learned in Trig, where when we're given an angle, or not the actual angle measure, but the ratio of a trig function to a given angle, and we're told either directly what quadrant this angle is in, or we're given some additional information so that we can figure out what quadrant angle A is in, we need to get that basic little diagram set up so that we can easily write any of the other 5 trig ratios for angle A and any of the other 5 trig ratios for angle B. So we can just, look at the diagram and write down whatever we need to know. So we're going to talk about angle A in pink or red. We're going to draw out an XY coordinate system and put an angle in quadrant 3. Okay, so in quadrant 3, we have a y value which is -1. Actually, the distance is 1, but we're indicating with a -1 that we're moving down. We have a r value, a radius of 3, and we're going to do a little bit of Pythagorean theorem here to find out what the other side of the reference triangle is against the x-axis. So we have x squared plus y squared is equal to r squared. That's going to give us that x squared is equal to 8 after you do 9 minus 1. We're going to square root both sides and get x is equal to the square root of 8, which is reducible because it has a perfect square in it. The square root of 8 is the square root of 4 times the square root of 2, and the square root of 4, we know, is equal to 2. So x, is equal to 2 square root of 2, but we're going to indicate that on our reference angle as a -2 square root of 2. That negative, again, indicating a movement to the left or down that we're putting on these values. We're not indicating that there's such a thing as a negative length, but we're putting those signs on there to indicate direction, and that's going to help us make sure that as we set up the other 5 trig functions, or whatever it is that we're asked for by these sum and difference identities, that we have a correct sign, just to help us with the sign. And we'd also be nice here if we show a little bit of arc to indicate that this is a standard position angle, and that angle A starts from the positive side of the x-axis. Now moving on to angle B, which we'll go ahead and color code that with a color blue, which really should be a little bit lighter. So just grab a different color here. Set up our XY axis in white. Quadrant 1. Reference triangle against the x-axis. We got a movement to the left of 1. A radius of square root of 5. Whoops, I still got the help me keep it straight line section. There we go. And we have x squared, which is 1 squared, plus y squared is equal to the square root of 5 squared. That's going to give us y squared is equal to, of course, the square root of 5 squared is just going to be 5, minus 1 squared. We have y squared is equal to 4, and y is equal to 2. Excellent. So now when we come down here to the difference identity, the cosine of a minus b, and it says, what's the cosine of a? I can just look at my picture and say, well, there is the x value along my reference triangle, my r, and the cosine of a is equal to negative 2 square root of 2 over 3. And the sine of b is going to be y over r, so y over r, and we have 2 over the square root of 5. So as we start cleaning this up, and have a little bit of simplification here to do, we have negative 2 square root of 2 over 3 square root of 5, and then plus a negative or minus, we have 1 times 2, which is 2 over 3 square root of 5. And we have negative 2 square root of 2 minus 2 over 3 square root of 5. Now, you may or may not see that as sort of like a final form of your answer. You might see that rationalized. So let's pick a different color. And let's say in pink, we're going to multiply the numerator and denominator by the square root of 5. If this were not a multiple choice answer, I would be happy with the radical in the denominator and not cause my kids to take more time simplifying and instead give you some questions in and test your knowledge of other trig concepts. But we have square root of 5 times the square root of 2 is the square root of 10. And now we have a minus 2 square root of 5 over, now the square root of 5 times square root of 5 is 5, and 5 times 3 is equal to 15. And that is our answer to example number 1. Now, moving on to example number 2, we're going to find the tangent of A plus B. Sure have enough room to write. And the tangent of A plus B is going to be equal to the tangent of A plus the tangent of B over 1 minus the tangent of A times the tangent of B. And this identity is asking for the tangent of A and the tangent of B, but we didn't try and find some way of just going directly to sine to cosine. We went ahead and drew those reference triangles and the angles in the appropriate quadrants for the given information. So now we can just look at those pictures and grab the information that we need. The tangent of A is y over x, so we have 1 over 2 square root of 2 plus the tangent of B, which is going to be, again, y over x, so we're looking at 2 over 1, or just 2. And that's over 1 minus the tangent of A, which again is 1 over 2 square root of 2 times the tangent of B, which is equal to just simply 2. At this point, we can find common denominators and write the numerator as a single fraction and the denominator as a single fraction, or we can look at each of the little fractions we have in the numerator and denominator of this fraction and say, hey, you know what? I want to get rid of this division of 2 square root of 2. I have that same division in the numerator and the denominator of this fraction. So how about we just go along, instead of finding common denominators and then creating a single fraction over a single fraction and then having to multiply by the reciprocal of that denominator, how about we just multiply the numerator and denominator by 2 square root of 2, which is just a form of 1, right? Anything divided by itself is equal to 1. And as we distribute this through the parentheses, let's see what happens. And we might have to do some more work before we say that we're finally done, but we've got 1 over 2 square root of 2 times 2 square root of 2 is going to be equal to 1. And then plus, we have 2 times 2 square root of 2, which is going to be plus 4 square root of 2 over 2 square root of 2. And here we've got in our second, well, let's see here. Yeah, let's just do this. This is all acting as a single term, right? I guess I could have just said the 2 divided by 2 are going to cancel. But seeing that how we have this multiplication of the entire 2 square root of 2, that's going to be what cancels out. And we're just going to have a second term in the denominator of just 2. Now, we still have a radical in our denominator. Chances are you're not going to see that as one of your multiple choice answers if this happens to be a multiple choice answer, and maybe your teacher is making sure that you rationalize the denominator. So now we're going to have to multiply the numerator and denominator by the conjugate, and that is going to give us 1 times 2 square root of 2, and 1 times 2 is going to be 2 square root of 2 plus 2. And then we're going to multiply into that second term all the way through, and we have 4 times 2 is going to be 8. And square root of 2 times square root of 2 is 2. So we have 8 times 2, which is equal to 16. And then one more step of the distributive property in the numerator, we have 2 times 2, which is 8. So we'll have 8 square root of 2. And in the denominator, we have, a form of a minus b times a plus b, and the whole point of multiplying by a conjugate is that's the factoring pattern of a squared minus b squared. It's the only 2 binomials you can multiply together and not get a middle term. So we have 2 square root of 2 times 2 square root of 2. 2 times 2 is 4. Square root of 2 times the square root of 2 is 2. So our 4 times 2 is giving us 8 minus, negative 2 times positive 2 is negative 4, so we have 8 minus 4, and we're looking at the 2 square root of 2 plus 8 square root of 2, giving us 10 square root of 2 plus 18 over 4. Everything we have here in this expression is even, so we can write our final answer as after taking out, now let's go ahead and show this, a factor of 2, giving us 2 times 5 square root of 2 plus 9 over 4. The 2 over 4 reduced down to be 1/2, and so our final answer is going to be 5 square root of 2 plus 9 over 2. Bam! Okay, now for our last example, we've got possibly for you a pretty unique question and a little bit challenging, I would say. We're going to be taking a look at this problem that says, find exactly the tangent of the acute angle between 2 lines with gradients of 3/8 and 5/8. So we have a line that is has a slope of 3/8 with a rise of 3 and a run of 8. And we've got a line that has, from this point to this point, a rise of 2 plus 3, which is going to be a rise of 5 over a run of 8. All right, now how are we going to tackle this? Find exactly the tangent of the acute angle between the 2 lines. So we want the tangent to the acute angle between the 2 lines. We're looking for the tangent of the angle that's between those 2 lines. We're looking for alpha. We want to know what the tangent of alpha is equal to. Well, what do we know in this problem so far? We know what, and can set up a tangent for beta. The tangent of beta with this right triangle here that we're looking at, maybe say between 2 points along this line with a slope of 3/8, or a y value of 3, a change in y of 3, and a change of x of 8, we have the tangent of beta is equal to 3/8. And while we don't have a right triangle that is describing some kind of ratio in the diagram for alpha, we do have a right triangle for the combination, the sum of alpha plus beta. See, if you go that entire angle of alpha plus beta, we have a rise of 5 and a run of 8. So we have the tangent of alpha, well, okay, beta plus alpha, since I wrote beta first, of 5/8. So we have the tangent of the two angles being added together, and it happens to be one of these angles is equal to alpha. What's the tangent of alpha? We know the tangent of beta, and we know the tangent of the sum of two angles. We have an identity that we can work through that's going to allow us to see the tangent of alpha, and effectively we're going to eventually get that tangent of alpha isolated. So we're going to be working with the sum formula for the tangent of two angles. Really similar to what we have here fundamentally with part B of this question, which I've seen in, like, say, my pre-calculus book a number of times, but here we have it presented in a different sounding and maybe a confusing problem initially, but you break down the picture and it kind of makes sense that we have the tangent of alpha plus beta is equal to the tangent of alpha plus the tangent of beta over 1 minus tangent of alpha tangent of beta. Okay, well, what do we know? We know that the tangent of alpha plus beta is equal to 5/8, rise over run for the combination of those two angle measures. And that's equal to the tangent of alpha, which we don't know, that's what the question is asking for, plus the tangent of beta, which is equal to 3/8 over the value of 1 minus the tangent of alpha times the tangent of beta again, which is once again is equal to 3/8. Okay, this is what we're going to work through. So we've got a number of ways, I'm sure, to figure out this problem. I'm going to go ahead and write the right-hand side of this equation as a single fraction. So we're going to put this over 1 and look at our 1 as 1 over 1 and find a common denominator by multiplying here 8 in the numerator and denominator and 8 here. So we've got that 5 over 8 is equal to 8 tangent of alpha plus 3 over 8 is equal to 8 minus 3 tangent of alpha over 8. And I'm showing this differently than I did the other problem, just to kind of give you a different look of how you can handle these fractions. We have 5 over 8 is equal to 8 times the tangent of alpha plus 3 over 8. And we're going to remember that when you divide by a fraction, you, of course, multiply by the reciprocal of the what you're dividing by. So we're going to flip that bottom up and multiply by the reciprocal, changing the division to multiplication. And now that we're multiplying by 8 over 8 minus 3 tangent of alpha, we're going to allow those 8's to cancel out. Have, just showing every single step, 5/8 is equal to 8 times the tangent of alpha plus 3 over 8 minus 3 tangent of alpha. Now all we're really trying to do is isolate this variable of tangent of alpha, but you cannot solve for a variable when it's in the denominator of a fraction, of course. So we're going to multiply out the, basically kind of like cross multiply, and we're going to get 5 times 8 minus 3 tangent of alpha is equal to 8 times 8 tangent of alpha plus 3, giving us 40 minus 15 tangent of alpha is equal to 64 tangent of alpha plus 24. We're going to add over the 15 tangent of alpha, and at the same time we're going to subtract both sides by 24, giving us 15 and 64 is going to be 79. Tangent of alpha is equal to 16. And so we have 16 over 79 is equal to tangent of alpha. So hopefully you're seeing a new style of problem that can give you another application, another look of how we deal with and how we'll be working with sum and difference of angles in trig. And if you happen to have this problem in your textbook, well, now you got another one to help you finish your homework. I'm Mr. True. Bam! Go to your homework.